Welcome to today's lesson. In this first tutorial, we will graph quadratic functions from standard form. We are in section 4.1 this time in our text, and it is graphing quadratics from standard form. Our standard form for a quadratic is right here. Let's put a nice bubble around it. It is y equals ax squared plus bx plus c. Our standard form for a quadratic has three terms. The first term is called our quadratic term. That's the term that has the x squared in it. The second term is called our linear term. That's the one with the x. And our last term is called our constant term, and that's just a number sitting here at the end. We have coefficients a, b, and c, and each one of them does something different to our graph. The value of a is the same value of a that we know and love from our vertex form. The value of b will do something today, and the value of c will do something today, and let's see if we can figure out what they do. Unfortunately, we do not see the value of h, we do not see the value of k, so from standard form it is a little bit trickier to find our vertex, but I'll show you how to do that today. Before we do that, I'd like to review graphing a function that is already in vertex form. Now this is called f of x, but remember that's just a fancy name for y. I can call my functions any name I want. This one is y equals or f of x equals. This is in vertex form, so it's a whole lot easier to find the vertex. And let's go ahead and do that. We've got the value of a, that's our value of 1 that's right here. We've got the value of h, which is negative 3. And we have the value of k, which is negative 4. So our vertex is negative 3, negative 4, and let's plot that. 3 to the left, 4 down. I'll put a little star there for my starting point. Since my value of a is a 1, that just means it's our normal outputs. So when I input a 1 to the right, I output 1 squared. And when I input a 2 to the right, I output 2 squared, or 4. I go back to the star. When I input a 3 to the right, I output 3 squared. That's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm probably not going to be doing the 16 output, so I'll come over here and I'll do some symmetry to get the 3 points on the left side of my star. And we'll graph these 7 dots into our nice parabola. And there we go. So what I'd like to do now that we've graphed that from vertex form, I'd like to take our function f of x equals x plus 3 quantity squared minus 4, and let's convert this equation into our standard form, meaning let's get rid of this set of parentheses, let's square the binomial and subtract 4, and get our terms to be side by side by side. So when I'm squaring a binomial, that really just means that I'm writing it side by side and multiplying them. And don't forget, of course, your minus 4. So I'm going to be foiling this, or you might call it a double distribution. X is going to be multiplied to the x to make x squared, and x is going to be multiplied to the 3 to make 3x. Then this 3 is going to be multiplied to this x, making 3x. And then it's going to be multiplied to the other 3 to make 9. And of course, don't forget that you're still subtracting 4. So here's our f of x, and that will be equal to, here's our x squared term. The 3x and the 3x are like terms, so they combine to make 6x. And the 9 and negative 4 are like terms, and they combine to make 5. So here is our standard form. It's the same equation, it's still f of x, it's just not in vertex form anymore, it's now in standard form. And I'd like to make some connections between the two. So the first thing is you can see that from standard form a is still the value of 1. It was 1 to begin with, and it still is the value of 1. And that is what we had over here and makes our graph have the normal outputs, if you will. The other connection I'd like to make is that the value of c is 5. positive 5. And if you look over here on the graph and count up the y-axis 1, 2, 3, 4, 5, you can see that we cross the y-axis exactly at 5. And that will happen every time when you have a function written in standard form. The value of c will always be your y-intercept. And that's helpful. It's a whole lot easier to find a y-intercept when you're written in standard form because it's just this number here at the end. So the question now is, if I gave you f of x from standard form, how would you be able to find the vertex? I know we know how to find a, and now I know how we find the y-intercept, but how are we going to use b to find the vertex? And that's what I'd like to do on our next slide. So let's rewrite up here. We have f of x was x squared plus 6x plus 5. That's the value of f of x, or that's the function f of x. And let's go through the steps to how to find our vertex. First, it's important for you to understand that we have the value of a, which is always the coefficient of our quadratic term. We have the value of b, which is the coefficient of our linear term. And we have the value of c, which is this number off here to the side. So we have a, b, and c. To find the vertex, we first find the x-coordinate of the vertex. And the x-coordinate of our vertex will be the opposite of b divided by 2a. This is how we find the x-coordinate of our vertex. We take the opposite of b and divide it by 2a. It's actually part of our quadratic formula that we'll look at a little bit later. So if we're going to be taking the opposite of b and dividing by 2a, we need to know what the value of b is and what the value of a is. Well, here the value of b is 6, so the opposite of that would be negative 6. The value of a is 1, so 2 times a becomes 2 times 1. And let's simplify this number. We have negative 6 divided by 2, which is negative 3. So the x-coordinate of my vertex is negative 3. Now, once I know the x value of any point on our parabola, we can just plug that x value into the equation in place of these x's to find the y value. So once we have the x value of our vertex, we're going to plug in to find the y value of the vertex. And that's how we find the vertex. So what we're going to do now is we're going to plug in. We're going to take this negative 3 and we're going to plug it in right there, and we're going to plug it in right there. Our function says we take our x and square it, so we will take our negative 3 and square it. And then we will add 6 times x, so we're going to add 6 times negative 3, and then of course we add 5, which is just plus 5. So we took this negative 3 and we placed it here, and we placed it here. Now we just have to simplify what this number is. So negative 3 squared becomes 9, 6 times negative 3 becomes negative 18, and plus 5 is plus 5. Now we have addition and subtraction, so we just do that from left to right, whichever comes first. 9 minus 18 is negative 9, then plus 5, and negative 9 plus 5 is negative 4. We found the y-coordinate of my vertex. So now I know that my vertex is negative 3 for the x-coordinate, and negative 4 for the y-coordinate. And I remember that from our previous example. So that's how you find the vertex when it's in standard form. Yes, sure, it's a little bit more complicated. We have to use this little algorithm to find the x-coordinate, and then we plug that value into the function to find the y-coordinate. But that's how you find the vertex. The axis of symmetry, remember, is always an equation. Always an equation. And that's going to be x equals, in this case, the opposite of b divided by 2a. Whatever the x-coordinate of the vertex is, x equals that number is our axis of symmetry. Number 3, we want to be able to state the y-intercept, and that's pretty simple. This is always an ordered pair. That's how I want you to write our y-intercept. And that will always be the point 0, comma, c. Whatever the value of c is, that is going to be our y-intercept. So since c was positive 5, 0, 5 would be our y-intercept for this graph. And finally, once we have our vertex, our axis of symmetry, and our y-intercept, we can just plot our vertex and we'll graph our parent pattern, parent function, just like we've done it before. So let's look at our second example. Here's example 2. This one I called g of x. Negative x squared plus 2x plus 3. Let's first find a, b, and c. A is the value negative 1, b is the value 2, and c is 3. So now I'm going to find my vertex. I'm going to start with negative b over 2a. Negative b over 2a, I take the opposite of b. Since b is 2, this becomes negative 2. 2 times a would be 2 times a is negative 1, so 2 times negative 1. So this becomes negative 2 divided by negative 2, which is 1. That is the the x coordinate of my vertex. Since I'm looking for my vertex, I think I'm just going to go right here and put my little x. Now I need to figure out what the y coordinate is. And what I'm going to do now is plug this 1 into my original function right there. So I've got the opposite of x squared and then plus 2x, so that's plus 2 times my 1, and then plus 3, so that's plus 3. Order of operations say that we must deal with our exponents first, so 1 squared is 1, and then we can multiply by that negative, so this ultimately becomes negative 1. 2 times 1 is 2, and then of course plus 3. Negative 1 plus 2 is 1, and then plus 3 makes 4. So there's my y coordinate, and I can plug that in. So I have my vertex, which is 1, 4. So let's plot that. 1, 1, 2, 3, 4. I'll put a little star. Once you have your vertex, you just need to figure out what the value of a is, but we've already found that, and that's the most important value to get all of your other outputs. It's a negative, so that means that our outputs are going to go upside down, but since it's still a value of 1, nothing else is changing. So I'm going to be inputting a 1, but instead of going up, I'm going down 1, and inputting a 2, but going down 4, and inputting a 3, but going down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll do my symmetry on the other side. And there is our parabola. Once you find your vertex and you know your value of a, you can graph your pattern. We'll come back and fill in all these other things as a try problem at the end of the notes. So I will come back to this example. Let's do one more, example 3, just to make sure we're good with this. H of x, 2x squared minus 4x plus 3. Again, let's pick off a, b, and c. A is 2, b is negative 4, c is 3. Now let's go find the opposite of b divided by 2a. This will be the x-coordinate of my vertex. The opposite of b, since b is negative 4, the opposite of that becomes positive 4. 2 times a would be 2 times 2. So this is 4 divided by 4, which is, well, look at that, it's 1 again. I'm going to come over here to my vertex and put 1 and then a comma. And then I'll go find my y-coordinate. Well, the y-coordinate, again, I'm just going to plug my 1 into my equation right in place of these x's. So I have 2 and then my x squared, which is a 1 squared, and then minus 4 times 1, and then plus 3. We must square first. 1 squared is 1, and then multiply by 2. 2 times 1, of course, is 2. Negative 4 times 1 is negative 4, and then a 3. Left to right now, because it's all adding and subtracting, so now we just go from left to right, whichever comes first. 2 minus 4 is negative 2, and then the plus 3. Negative 2 plus 3 is a 1. Look at that. So we inputted a 1 and we outputted a 1. So our vertex is 1, 1. So let's plot that. 1, 1 is right here. And now let's look at my value of A. That's going to help me find all my other outputs. This time it's positive, so we are going to be opening upward. And since it's a 2, I'm going to be doubling all of my outputs. So normally when I input a 1, I output a 1, but in this case, I go up twice as much. Normally when I input a 2, I output a 4, 1, 2, 3, 4, but this time I go up twice as much. So I go another 4, 1, 2. It is a little off the graph patch, but I'm going to put that right there to help me with my graph. Looks like that's all I'm going to be able to do. I'll do symmetry on the left side, and I'll come over here and approximate that to be right there. So there's our parabola. Okay, so now that I've shown you 3 examples for how to find the vertex from standard form, and we've practiced graphing 3 more parabolas, I'd like you to pause the tutorial right now and fill in all the other pieces for example 2 and example 3. Find the axis of symmetry, the domain, the range, the roots, the zeros, the y-intercept, the increasing intervals, the decreasing intervals, and the end behavior. Do that on your own as a try, and then unpause and make sure that you have the correct answers. Pause now. Thank you. Okay, thank you for trying these on your own. This is the example 2. These are the answers to example 2. Our axis of symmetry, x equals 1. The domain, of course, is all reals. I chose set notation. Our range goes up to our y-coordinate of our vertex with a bracket inclusive. Our roots, another name for zeros or x-intercepts, I wrote those as ordered pairs. Notice that the y-intercept is the value of c, right here 3, so 0, 3. Increasing and decreasing intervals depended, of course, on the x coordinate of our vertex, and I chose to write with my plus or minus symbol, and instead of calling this y, this does have a fancier name. It is called g of x, so in my end behavior I'm using the g of x. So erase that y if you put it and put g of x in its place. Let's look at our example 3 solutions. Our axis of symmetry, again, is the value of 1, so x equals 1. Domain is all reals. This time my range started at the value of 1 and then went up to infinity with a bracket on the 1. It did not cross the x-axis, so I wrote no real zeros. If you would prefer to put the null set symbol, that's fine. Maybe you put it in the O's of the no and the zeros. The y-intercept is an ordered pair. Again, it's the value of c, which happens to be 3 again in this problem. Here's our increasing and our decreasing intervals, and this one has the fancy name h of x. So in my end behavior, I use the value of h of x. So I hope that you got all of those answers correct for your parabolas, and we'll practice this more in class. We'll see you then. Thanks for watching.